Hey there, welcome back to the channel. Today we're going to put new bronze valve guides into this head. Let's get to it. When a head has a lot of miles on it, one of the things that wears out is the guide. The guide is this hole down here. We'll take a look here in a second, but it's that the stem of the valve passes down through. If you recall, when I pulled this apart, there was a whole bunch of carbon on the intakes. That's due to oil coming down the guide and then baking onto the back of the valve. The intakes also have a similar problem. There are a few different ways to check for wear. The most accurate way is they make tools that are micrometers specifically for measuring these. Most guys, especially home builders, don't have access to something like that, and it's not worth spending the money on a tool that is that kind of quality for doing just one or two heads. Instead, we're just going to use a couple of valves and take a look and eyeball it. So that hole right there and right there, those are the guides. This is a valve and this is the stem, and quite obviously the stem goes down in there like that. Now, if I lift it up, hold it with my finger so that the end of the valve, and I'll show you here. So if we look right here, I'm going to hold it so that the end of the valve is right here. Now if I take this valve and move it, you can see how much that's rocking. That is actually really bad on this one. That's got a lot of wear. That should be pretty tight tolerance. Let's take a look at the intakes. The intakes aren't as bad on this head. So you can see it's moving, but just a little bit. So this one is worn quite a bit. This one is a little. The second check we can do is to see if it actually is providing a seal. If you take the valve, put it down in, and again, hold the bottom with your finger, make a seal with your finger on the other end of the guide, and pull. You hear that noise? Let's do that again. So you can tell from the sound that it's generating a vacuum down in there as I pull this up. Then when I release, the air is rushing down into the guide. So it's getting enough of a seal between the guide and this stem to prevent air from sucking down in. If I try the same thing with this exhaust, it makes a little bit of a pop, but not much. You can actually feel it on your fingertip as you pull up the valve. You can feel it sucking on your fingertip. So that's another way to tell. If it's not getting vacuum, they're really, really worn. This head, basically all of the exhausts are worn to the point they definitely need replacement. The intakes, they're kind of 50-50. You could probably go with it. The reality is, if the exhausts and intakes were all about the same, this one would probably be just a candidate for new seals and send it. Okay, we know the guides are worn out on this head. What are our options? The first one, the easiest and most expensive, is to just take this head over to the machine shop, say, hey, it needs new guides, and they'll be happy to take your money and put new guides in. Now, my luck with machine shops lately hasn't been that great, so first of all, I don't really want to pay somebody else to do it when I know how to do it myself, and second, I don't know that I trust anybody else to do it around here. So we have two other options. First is we can replace the guides ourselves. Second is you can actually do what's called knurling the guides. I have all of the tools to do both a replacement and a knurl. Today we're just going to do straight replacement. Primarily because, well, I need this head to go back into the dart, and replacing the guides is a better option. Knurling is also interesting, and I think it's a completely valid repair. 'So I've got a separate head. We'll probably do that on another day. Replacing guides is, in theory anyway, a real simple thing to do. The guide that we saw down here, we're going to drill it out and then ream it to a specific size. Then we take a bronze guide and we press it down in there. And then we cut off one of the ends to make it the right length, so it's the same length as that. And then we're done. And you can see I'm trying to rock it in here. There is zero play in this. I mean, that is a nice, smooth fit. And that's what we want. So we're basically going to drill these holes out to the outside diameter. Well, I guess we're going to drill it to a little bit smaller than this. Then we'll ream it to this diameter. And I think it actually reams to about 2/1000ths undersize. So the hole will be 2/1000ths smaller than the outside of this. Then we're going to drive this in, cut it to length after it's been driven in, and then all we have to do is put in the valves. So let's see how that works. We have here a Lisle 59000 valve guide installer. This was made in 1978, so some really old tech, but it's still perfectly valid today. I've got this on loan from Dr. Torque, and to be honest, I'm pretty excited about doing this. This is going to be a fun job. It also has the instructions for the 58000, which is actually for installing valve seats. He doesn't have the tool, but I'm on the lookout for one. If you've got one of these or you know where one is and you're looking to get rid of it, let me know down in the comments. This is the part we have here though. This is this tool set. We have some pilots. The drill. The reamer. And then this is our alignment tool, this big C-clamp looking thing. And then we've got some different seats for different types of heads. Generally speaking, the operation is going to work like this. We set this tool up, and we use this setup pilot to make sure that we are perfectly in line. We're going to use some cups. I guess these here. I'm going to use a cup on one side. And we may need one of these. Then we're going to take this bit, run it all the way down through, and drill it out. So this bit is close to the size of that guide. Once we've drilled it out, we use this reamer. This reamer is again about 2/1000ths smaller than the guide itself. So we ream it out. Then we'll remove this tool. And these are some old school ones here. This is a driver. You basically put the guide in and use this and just hammer it down in. You can see how mushroomed out it is. So these have been used. There's another one. I have the pneumatic version, so at least we can save ourselves a little bit of headache there. We'll just drive them in with that. Once we have them driven in, we actually have this tool. It's got carbide bits, and we'll use one of these. So you put this down into the guide, and then this cuts it down to length. And we just drive this with a drill. So let's get this head set up and do a valve so you can see how it all works. The first thing we need to do is choose our setup pilot. This is the largest one in the set. Basically, you drop it down in the guide, and you want the pilot that is as close to tight in this guide as you can get. This one is about the same diameter as those valves, so It's got a little bit of a play to it, but not too bad. And this is as close as we've got. So this is the pilot we're going to start with. Next, we need the adapter for this end and for down underneath. The top adapter, it's got this 45 cut. That's going to fit right down in the seat. I want to make sure that it fits in the seat, but it's not hitting anywhere up on the head here. The lower one, I'm using the largest one out of the set, and I'll show you how that works. You want one that fits all the way down onto the spring seat. You want to make sure that it isn't hitting, like this seat has a little bit of a land here. We don't want it hitting that, so we want it all the way onto the seat. Next, we want to open up the C-clamp tool so that it's big enough to fit around the head. And we take the cup, put it on here, and then put it over the guide down at the bottom. Next, we're going to take this, drop it in at the top. Now our pilot is going to go down through the whole setup, through the guide, and it fits all the way down into a hole down here. And then we tighten it up. I can get all the crap out of the way. Make sure that it's seated properly up here. This part is really critical. This has to be straight, or your valve guide that you drill out will not be straight, and then the valve won't be straight. This needs to be exactly right. So double and triple check what you're doing. You can see here, I'm on the seat. Check all the way around, make sure it's on that spring seat. It's not on any casting, it's only on a machine surface. Make sure that the tool isn't impacting the head anywhere. Make sure that we're fully seated here and that it's fully seated. This adapter is against the valve seat. All right, we are now aligned and set up. I'm going to swing the head around so that I've got an angle right now. We're kind of coming back toward ourselves. I'm going to swing it around so that this goes away from us, a little easier to see. Okay, I've swung the head around and I moved the tool from down there to here so we can see it a little better. You can see this is our pilot here. It's going through this adapter and it goes into the adapter back at the back. Okay, once we have everything aligned here, we have to put in a bushing. And there are two different bushings with the kit. They're a different size. So we take out the pilot. Notice this is a little bit loose. The shoulder on this pilot only fits through one of these. So it fits through this one. It does not fit through this one. So we need to use the one that it'll fit through. Put the bushing all the way in and put our pilot in again. This time we have to line it up through everything. All right, so it's through this bushing, through an adapter here, through the guide, through an adapter at the back, and into basically the backside of this tool. We now know that it's a straight shot all the way through here. So we're going to tighten up this tool, the clamp. Once it's tight, we now have to remove this pilot. And now we have a hole that goes straight through here that is perfectly aligned. Next, we swap out this bushing, take out the larger one, and we're going to put in the smaller one. The difference here, the drill, if we look at the smaller one here, It's a nice tight fit. There's no slop. The one that we used for the pilot, it's got a lot of slop. So we move to the smaller one. And see, our bit goes down in. Perfect size. Once we've swapped the bushings, we're going to take the drill and put a little tap magic on it for lubrication. The toolkit comes with this drive adapter, so it's square on this end to go onto the drill, hex on this end for our drill itself. I've got the drill set to slow speed, and now we just drill out this guide. Now we go back to the larger bushing. This one fits the reamer nice and tight. Again, I'll put some cutting fluid on the reamer. All right, now we can remove the frame and the adapters. There will be a lot of chips in here. And this adapter was full of chips as well. Okay, so here's our valve guide. Some guides are asymmetric. They're different on each end. So look at them. If there are spiral cuts on it, that's going to be toward us because it's the end that we're going to remove. For this kit, we cut the valve guide down to size on this side. If you're using a large machine tool, you actually probably start from the other side. So this would go face down on the machine. All the machine work and the guide installation would come from the top. But since we're doing manual, we're coming in from the bottom. As I mentioned before, the kit comes with a driver that is manual that you just use a hammer for. I bought one of these. So this is an air version of it. It's just going to go into an air hammer. The end of this just goes into the guide, just like that. When you install the guide, just give it a light coat of a light oil. Something like WD-40 works fine. As you drive it, put your finger on the guide back here, so as soon as it reaches the end, you want to stop. So your finger is the depth gauge. All right, let's take a look at the other side. You can see that guide is right to the top here. And we'll take a look in here. The guide is sticking out, looks like quarter, maybe even 3/8 of an inch this direction. It's a little hard to get an angle on it that makes it obvious, but it's sticking toward us. Like I say, about 1/4 to 3/8 of an inch. So that is what we need to trim off. Next, we need to take this spot facer tool, and we're going to trim that down to the cast iron. There are 3 pilots of different sizes. You want to make sure you find one that fits, but it's not too tight. That guide has been smashed in a little bit, so the diameter is smaller than a valve right now. We don't want this getting stuck down in there. It doesn't have to be a perfect fit, because all we're doing is trimming it. It doesn't have to be exactly centered. This goes in here. You can see it's got a little step here. So we want this in there, and then we can tighten this down. And we're going to use a drill to cut. And just keep checking it as you go. We're just trying to drive it down to the cast iron. It turns out that this spot facer, the carbides on it are just horribly dull. In fact, I don't know that they're carbide. They might just be high-speed steel. Regardless, this thing takes 20 years to do one guide. I'm not going to try to do 12 with it. The rest of these, I'm definitely going to cut shorter with the lathe first, then push them in, and then trim off like the last 1/16 of an inch. Once you've got the guide cut down flush to the cast iron, you can go ahead and repeat the process for the rest of the valves. Just a couple notes on these valve guides. This guide is a general purpose guide, can be used for a lot of different heads. The outside of it is 502 thousandths wide. This reamer is 500 thousandths. So there's a 2 thousandths interference when you push this in. And that's good. When you press it in, it fits nice and tight. You get good, contact between this guide and the head. Allows heat to transfer. Also keeps the guide in place. They're also longer than they need to be. This one's longer by probably about 3/8 of an inch. So I just cut them off on the lathe and put them in. The other critical dimension is the inside. The inside of this is 374 thousandths. So brand new, fits on the guide real nicely. Right, I can turn the guide, but it's real nice and tight fit. Problem is, when you press this into that hole, that 2 thousandths has to go somewhere. And what happens is it squeezes this in. Once it's in, there's no way to push this stem through the guide. It actually shrinks by about 2 thousandths, this hole does. So sometimes you might be able to get it in maybe about that far. At any rate, you can't push it all the way through. The guide itself, the inside, gets kind of shaped like an hourglass. So it's pretty wide at both ends, but it tapers in and then back out. So you have to ream the inside of this to the size of the guide after you press them in. Since I'm doing this with pretty much common hand tools, I'm just using my Milwaukee drill, so I need to run the reamer through. Trying to go up 2 thousandths with a reamer, especially with a hand tool, you're just not going to get it. It's going to bind and probably either twist your wrist or get stuck in there, and then you're going to have a reamer stuck in the guide that you can't get out. So what you do is you enlarge it to 373. So originally it's 374. You push it in and it gets pushed down to about 372. So we ream it out to a 373, and then again to a 374. Once you've reamed it out, the valve then fits nicely. This head needs to be cleaned up. There's a whole bunch of chips of cast iron and bronze, so this isn't actually assembled. I'm just checking for fit. But we'll go through, get it all cleaned up, then lubricate these stems, put them in, and reassemble. That's all there is to it. Thanks for watching.